Now let's look at volume word problems. We're going to just review general volume, but then we'll review volume of cylinders and prisms, volume of cones and pyramids, and then volume of spheres. So volume generally refers to capacity of a three-dimensional object. It's usually the product of the ratio of the area of the base to the height of the object or container. So for volume of cylinders, we have V, which is the volume is pi r squared h, which pi r squared is the area of the circle and h is the height of the cylinder. The rectangular prism is volume is length times width times height. Length times width is the area of the rectangle and h is the height of the prism. A triangular prism is half base times height. The base times height represents the base and height of the triangle, and the uppercase h is the height of the prism. And for a cube, you have V volume equal to side cube. That's because all the base has the same side as the height of the cube. The volume of pyramids and cones would be the product of area of base and height divided by 3. So for a cone, it's going to be 1/3 the volume of a cylinder, and a rectangular pyramid is going to be 1/3 the volume of a rectangular prism. A triangular pyramid is 1/3 the volume of a triangular prism, and a square pyramid is going to be 1/3 s squared. S squared represents the area of the square base, and then h is the height of the pyramid. And for a sphere, the volume is 4/3 pi r cubed, where r is the radius of the sphere. So let's take a look at some of these volume problems. It says a rectangular tank is 90 meters long and 45 meters wide. What is the capacity of the tank if the depth of the tank is 12 meters? So the volume is going to be the length times the width times the height, which is 90 meters times 45 meters times 12 meters. So 45 times 12 is 540 times 9, 540 times 9, so we see this as 4860. So this is going to be 48,600 cubic meters. A cylinder has a diameter of 12 centimeters and a height of 18 centimeters. During an experiment, a student is expected to fill the cylinder with tennis balls. How many tennis balls with radius 6 centimeters will be required to fill the cylinder? So the volume of the cylinder, is pi r squared h, which is pi times 12/2 squared times h, which is pi times 6 squared times 18. This is going to give us 36 times 18 pi. So let's call that 648 pi. Now we have a tennis ball with a radius of 6 centimeters. So a tennis ball is more of a sphere because it's a three-dimensional circular object. So the volume of a sphere is equal to 4 over 3 pi r cubed, which is 4 over 3 pi times 6 cubed, which is going to give us 4 over 3 pi times 6 times 6 times 6. This, so 6 times 6 is 36 times 8, 288 pi. So this is going to be 288 pi. Now we want to find out how many balls will fit. This is cubic centimeters, this is cubic centimeters. We want to find out how many balls will fit in the cylinder. So number of balls is equal to 648 pi cubic centimeters divided by 288 pi cubic centimeters. So let's get rid of this first. 648 divided by 288. Let's divide both of them by 36. We get 18 over 8. We divide this by 2. 9 over 4, which is 2 1/4. So we have 2 balls can fit in the cylinder. A prism has a triangular base of 84 inches and a height of 20 inches. The height of the prism is 40 inches. If the volume of the fluid in the prism is 21,000 cubic inches, what is the height of the fluid? So let's look at the capacity of the prism. Capacity of the prism, which is same as volume, is 1/2 base times height of the triangle multiplied by the height of the prism. So this is going to be 1/2 of 84 times 20 multiplied by 40. So this is going to give us 42 times 20 times 40. So this is 168. 42 times 2 is 84. It's 1680 times 20, which is 33,600 cubic inches. This is when it's full. But what we know here is that the only thing that changes is the height of the prism. So let's look at that. So if capacity is 21,000 cubic inches, then 21,000 is equal to 1/2 84 times 20 times H1. Let's call it H1. So let's simplify this. It's going to be 84 times 10 times H1, and then here we have 21,000. So let's divide by 84 times 10. We divide this by 84 times 10. So that crosses this out. 0 crosses this out here. 2100 divided by 84. If you plug that in your calculator, you should get 25, which is equal to H1. So therefore, height of fluid is equal to 25 inches. Finally, the diagram below shows the dimensions of the barn a farmer uses to store his grains. What is the capacity of the barn if it is completely filled? So the barn has two shapes. We have a cone. So the barn is going to be volume of cone plus volume of cylinder. So the volume of the cone is 1/3 pi. The radius is 4 squared, and then the height is 3. The volume of the cylinder is pi 4 squared times height, which is 10. So this is going to give us 16 pi plus 160 pi, which is going to give us 176 pi cubic feet of grains.